One of the themes we've seen a lot so far together is what happens when we take an object, a solid or any kind of figure, and dilate it by a certain scale factor and see how it impacts the area. And now let's see how it impacts volume. So let's take a look at this cylinder, and I want to compute the volume of it as is, and then I want us to compare that to the volume of the cylinder we'd have if I took this length and actually cut them each in half. So multiply each of these lengths by half. So we're going to sort of shrink the whole thing down, and let's see what the impact is on the volume. So first let's find the volume as it stands. That's pretty easy, because what do I see? I see it's going to be pi r squared h. And so I've got pi times r squared. That's going to be 64 times h, which is 20. And so what I see here is 1,280 pi. Okay, so, and what are the units, by the way? The units are centimeters cubed. But I want us to focus on this number. All right, now let's see what happens when we cut each of these lengths in half. So I make this a 4, I make this a 10. And now let's compute the volume of this smaller cylinder. Okay, well actually I'm going to do it out and write it exactly as we would if we were dividing these things by 2. So check this out. So it's going to be pi times r squared. That's going to be, I'm going to write this out, that's going to be 8 over 2 squared, right? That's the half of 8 squared, times the height, which is 20 over 2, half of 20, and that's the answer. But if we just now simplify this, what we see here is pi times 8 squared, which is 64 over 2 squared, which is 4, times 20 times 2. Looks very familiar to what we've already seen, except for those denominators. What does that equal? Well, the 4 on the bottom multiplied by the 2 on the bottom gives me an 8 on the bottom times, well, what we had left over. So 1,280 pi centimeters cubed. Now you can actually work out that number. That number, if you care, is actually 160 pi. But that's not the point. The point is to look at this number right here. How does it compare to this? Well, this number is 1/8 of the original number. 1/8. Now, where did that come from? Well, we took each length and we actually multiplied it by a half. But when you're finding volume, it's units cubed. So it's actually a half times a half times a half. And what's a half times a half times a half? It's an 1/8. And that's what we're seeing here. So the impact that we have on volume when we shrink the lengths is that we have a shrinkage in the volume, but not by one factor of that length factor ratio, but that thing cubed. In this case, a half times a half times a half. And so again, we can see how volume and before surface area is impacted by dilation.